Welcome back. This is Mr. Wakefield, and we are looking at our new worksheet packet here in Math 71 with section 6.1. It mentions rational expressions. A rational expression, you guys, is basically a fancy way of saying a fraction, okay? But it's not just any fraction. It is a fraction with a polynomial in both the top and the bottom, both the numerator and the denominator. Remember, the top is the numerator of the fraction, and the denominator is the bottom of the fraction. Okay, so when they say simplify the rational expressions down here, that means to simplify the fraction. And when we simplify a fraction, that's just another way of saying put the fraction in lowest terms. Put in lowest terms. It's just a different way of saying it, that's all. Okay, now, a number of times already this semester I've mentioned that if you have more than one term, a polynomial with more than one term in either the top or the bottom, or in the case of this problem, both the top and the bottom, okay, do not even think about canceling, all right, at least until we get to chapter 6. Well, we just got to chapter 6. So I'll show you how that you can sometimes cancel even when you do have more than one term on the top and bottom. We just didn't have the ability to do that before. Now that we are here in chapter 6, we do, and I'll show you that. But before we do that, let me just review with you how you do cancel when you have a single term on the top and bottom here. We did that back in chapter 1. Here's an example here. What we do is we divide the coefficients, we reduce them by dividing by a common factor until we can't do that anymore. Negative 9 over 1, the only thing you could divide into negative 9 and 1 is 1, and that wouldn't make it any lower if you divided by 1. Wouldn't make the numbers any lower, and so that's why those numbers are in lowest terms. And then when you get to the variable part, you subtract the exponents, okay? Let's review that here again. Let me just rewrite the problem here a little bit bigger so that it's easier to cancel. And in fact, I need to give even more space than that so we have room to write stuff when we do cancel. There we go. That's a little bit better. So, 9 and 3. What's a common factor of 9 and 3? In other words, what's a common number that we could divide into that? Well, it would be 3, right? Okay. And we get 3 over 1. You still got to check to see if this can be reduced anymore, the 3 and the 1 I'm talking about. But the only thing you can divide into 3 and 1, both of those, is the number 1. And so that's not going to make it any lower. Therefore, 3 and 1 are in lowest terms. Then we go to the variable part, and only if the variables are the same letter are you allowed to do this, but you can subtract the exponents. 3 minus 1, you always got to do the bigger one, even if it's on the bottom, you do the bigger one minus the smaller one, okay? And 3 minus 1 is 2, and you always put the answer wherever the bigger one originally was located. You always put a 1 wherever the smaller one was located. And finally, y, you got 5 minus 1, okay? You always doing the bigger one minus the smaller in that order. Canceling these out, and then the answer, y to the 4th, goes wherever the bigger exponent was once again. And then this one is 1, because you always put the 1 where the smaller exponent was. What's all this equal to, you guys? 3 times x squared times 1 on top. And on the bottom, we have 1 times y to the 4th. And there you go, okay? We're going to see stuff that's kind of similar to this here moving forward, but mostly we're going to see a lot of brackets here, okay? And the reason why we're going to see a lot of brackets in these problems here moving forward is because here's the thing, you guys. When you have a polynomial, no brackets yet, but just a polynomial. In this case, we have a trinomial on top and a trinomial on the bottom. Tri meaning 3 terms, right? When you have more than one term in either the top or the bottom, or in this case, both places, you must factor the top and the bottom first before you even think about canceling. Otherwise, you'll definitely be canceling the wrong thing. Okay, no doubt about that. So we need to factor these things. And you can see that both of these have a GCF of 1, but they also both look like the Berry method. Okay, so I'm going to do the Berry method on both of these. What do we get on the top here? We get, you can see here that that would be -5, with the middle number being -4. And sure enough, -5 and -4 means that my numbers are going to be 1 and -5. 1 and -5. So that means that we get x plus 1 and x minus 5. X plus 1 and x minus 5. That is now done factoring because both of those brackets have 2 terms. Both brackets have 2 terms in them with x to the first power. That is an automatic prime situation. So as I was mentioning in the last section when we were setting the brackets equal to 0, which we're definitely not going to do here, but I was highlighting the fact that when you have just 2 brackets, that's 2 factors. By the way, I'm always going to make the factors that have more than one term, and I'm going to make those red. I'll get into all that here in just a few minutes. But just 2 factors here when you have just 2 brackets being multiplied. Okay. Now, on the bottom, kind of a similar thing here. The Berry method tells us what? Tells me that 1 times 4 is 4, so that number goes on the top right there. And then the middle number is 5. So what 2 numbers are factors of 4 but add up to 5? 1 and 4. Okay. Since they're both positive, we're going to say x plus 1 and x plus 4. Once again, you guys, we got 2 brackets that are both prime for the same reason as it was up there, okay, on the top. Okay, 2 terms, x to the first power. That means the bracket is automatically prime. Okay. Now, once you factor both the numerator and denominator, which we did, completely, which we did, and once you identify your factors, and again, if you just have 2 brackets in either the top or the bottom, that gives you 2 factors. So I've identified my factors. I know I have 2 of them. 2 red ones on both the top and the bottom. Again, red means that they just have more than one term. That's all that means. Here's the thing, you guys. The red ones, the ones that have more than one term, they have special rules, all right? With one exception, which I'll show you here in a few minutes. The only time you can cancel a red one on either the top or the bottom is if there is another one either above or below it that's exactly the same. Exactly the same. And so that's why I can cancel these. Okay. And by the way, when I cancel 2 brackets that are exactly the same, you always get 1 over 1. 1 over 1. All right. Now, let's talk about this here. Can I cancel these x's right here? No, I cannot. Okay. You can never cancel part of a red factor. You either got to cancel the whole thing like I did with x plus 1 and x plus 1. Okay, notice I didn't cancel the x's only, okay, or the 1's only. Or I didn't cancel them separately. No, you have to cancel the entire red factor or you don't do it, you don't cancel the factor at all. It's all or nothing with the red factors. So you can't cancel just the x's and then leaving the 5 and the 4 there. That's not acceptable. All right, so therefore we cannot cancel these. So again, let's review. With the red factors, you can cancel them if they are exactly the same, but you cannot cancel just part of them, okay? So it's either all of it or none of it. And the only way you can cancel all of it is if there's one above or below it that's exactly the same. Again, there'll be one exception to that I'll show you here in a few minutes. So with that in mind now, what do we got left? We got 1 times x minus 5. All right, and when you multiply positive 1, not negative 1, as we'll see later, but positive 1 times x minus 5, that is equal to, because you're multiplying by 1, it's just equal to x minus 5. You don't need the bracket when the bracket's being multiplied by 1. You could keep it if you want, but you don't have to. Same thing on the bottom. 1 times a bracket, it's just equal to the inside of the bracket. It's like you're distributing almost, okay? And then there you go. Oh, but you might be thinking, oh, I really want to cancel those x's still. Okay, Let's say you're at the very end of the problem, you guys, and you circle your answer, but you're still having doubts about whether or not it's in lowest terms. Okay, let's talk about that for a minute. All right, let's pretend like we want to make sure this is in lowest terms. Pretend like this is the beginning of the problem now. If this is the beginning of the problem, this is prime because it has a GCF of 1 and it has two terms with x to the first power. Whenever you got a prime polynomial, and that's all you got on either the top or the bottom, okay, and this is going to be prime for the same reason down here. All right, whenever you got a prime polynomial on either the top or the bottom, that's just one red one, assuming it's got more than one term. That's when you do red. All right, we'll do green when it's a single term. I'll get to that in a few minutes here. But whenever there's more than one term on either the top or the bottom, but it's a prime polynomial, that's just one big red one because it didn't break down to two or more red ones or two or more factors overall. Okay, so looking at this, just to make sure it's in lowest terms, remember you can't cancel a red one unless there's another red one underneath it that is what? That is exactly the same. Okay, and you're not allowed to cancel part of a red one like we said a minute ago. This is why I know that this is in lowest terms. I can't cancel anything else. I can't make it any smaller by canceling. That's when you know that it's in lowest terms. Okay? You've canceled everything that you possibly can. Let's keep going here. We got more than one term on both the top and the bottom, so that should automatically tell you guys that, hey, we have to factor everything before we even think about canceling. Okay? So on the top there, I get a GCF of 4x squared with a bracket of x plus 2. By the way, that x plus 2 is prime. It's not one of those ones where you get two brackets after you do the GCF because it's got two terms with x to the first power. Whenever you got a GCF times a bracket, we saw this in 5.7, that's a green times a red because the green factors are always the single term factors. The green factors are always the single term factors. The red ones, of course, are the ones that are more than one term. So red times green when you have a GCF times a bracket. How about down here on the bottom? That's a couple of steps right there. There's a GCF of x, but when I factor that out, you can see here that I can factor the leftover part, can't I? Isn't this, let me bring it down. Isn't this, and don't forget to bring down the x on the outside too. The original GCF has to stay in the answer, remember. But that's going to end up being x minus 2 and x plus 2 when you get the x squared minus 4, right? Okay, x squared minus 2 squared, x minus 2, x plus 2. That was from section 5.5. Okay. So when you have, as we saw in 5.7, when you have a GCF times two brackets, that is a green and a couple of reds, a total of three factors, a green and a couple of reds. Okay, let's stop here for a second. When you have green ones, you guys, the rules are different than they are for the reds. The green ones are easier. The green ones, if you got a green one on both the top and the bottom, okay, and if the green one is only on the top or only on the bottom but not in both places, then you can't cancel it at all. You have to match up a green one with another green one. Okay, but the difference between green and red is that the green ones don't need to be the same. You just need to have one on the top and one on the bottom. Then you can at least try. It doesn't mean it's always going to cancel. Sometimes it's already, the green ones already be in lowest terms, but usually you'll be able to cancel something. But it doesn't need to be the same like with the red ones. Okay, we just cancel those the same way we canceled these right here. All right, when you have two green ones, one on top and one on the bottom, you cancel it exactly the same way as we did here. And so let's try that here. The 4 and the invisible 1 here don't cancel, the invisible 1 in front of the x. But we do know that x squared and x cancel. Since they both are x, the x variable, we subtract the exponents. 2 minus 1, x squared minus x to the first, 2 minus 1, and we get x to the first on the top with the 1 on the bottom. Again, the answer always goes where the bigger exponent was. Now you can see that 4x over 1 is what we have. Is that in lowest terms, or can we cancel some more stuff? No, that is in lowest terms right there, 4x over 1. You cannot reduce that. It's just like a separate, treat it like it's its own separate problem right here, okay? And you get that thing in lowest terms. If it's in lowest terms, then leave it alone after that, okay? Then you immediately go over to the red ones, and what is the rule on the red ones? We can cancel them if they are exactly the same. So be careful here. X plus 2 and x minus 2 are not exactly the same, because the plus 2 and the minus 2 aren't the same. Okay, but we can cancel these two because they are exactly the same, right? And because they are, we can say 1 over 1. That's what we always say when we cancel two red ones that are exactly the same. And now I am done canceling the red ones, all right? Because the only red one I got left is the x minus 2, and there isn't another x minus 2 up above it that you can cancel with it. So what do we got left here? We got 4x times 1 on the top. 4x times 1 on the top. On the bottom, we have 1 times this bracket times 1. And as you guys know, when you multiply by 1, again, that doesn't change anything. So the answer is just going to be x minus 2. And when you multiply bracket times 1, again, you don't need to keep the bracket. You just say x minus 2. Okay. Oh, but I'm really tempted to cancel the x's here, or maybe even the 4 and the 2. No, again, you can't, because 4x, if you were to treat this, again, if you're unsure about whether or not it's in lowest terms and you're thinking about canceling some stuff still, remember, treat this like it is the beginning of the problem. You have to try to get it into lowest terms, all right? Pretend like it's the beginning of the problem. Whenever you have just a single term on the top and bottom, you don't need to factor that. We only need to factor 2 terms, 3 terms, and 4 terms, just like we learned in the last chapter. So a single term, just leave that alone and call that a green one, since it's a single term. Since this is a prime polynomial down here, that is a single red one. And don't ever, let me make this clear, don't ever combine green and red. Don't ever cancel green and red. We always do what? We always do red and red, or green and green, as we saw here. But you never do green and red mixed together, okay, when you're canceling above and below. All right? It's got to be the same color. And so that's why I can't cancel anything. All right? Can't cancel green with red. That's not the only reason why you can't cancel, but that's a good enough reason. So let's keep moving here. All right, here in problem D, again, as I talked about, if you have a prime polynomial in either the top or the bottom, which is the case with x plus 1, GCF is 1. It has 2 terms with x to the first power. Prime polynomial, as long as it's more than 1 term, it's just a single red one. Okay, it doesn't break up into multiple red ones. It's just a single red one. The bottom, though, looks like the Berry method. And in fact, it ends up being what? It ends up being, aren't these two numbers here going to be -3 and +1? Okay, and so that's why we're going to say x minus 3 and x plus 1. So that's 2 red ones right there. Notice there's no green ones in this one. If there's no green ones, or if you have a green one in just the top only or the bottom only, then you skip the green step. There's nothing to cancel. Only if you have a green one in both the top and the bottom, like in the last problem, can you consider even canceling with the greens. So then we go to the red ones, and we can cancel if they are exactly the same. What do we write when we cancel 2 red ones that are exactly the same? 1 and 1. It's not nothing, you guys. It's 1, 1 and 1. All right, and that reminds us then that the top is not nothing. It is still 1. That's what's left over. And then on the bottom, we have 1 times a bracket. Once again, we've seen that a lot already. 1 times a bracket is just equal to the inside of the bracket. And there you go. Okay, in problem E and F, or pardon me, problem E, F not so much, but something unusual happens here in E. Maybe you've seen it before, but we'll go over that carefully. All right. Let's first of all do our normal thing here, and then I'll talk about that. 5x minus 2 is prime. 4 minus 25x squared. Please, you guys, do not reverse these terms around. A lot of people think, oh, this is one of those square minus square problems. I'm more comfortable with the x being in the front. Well, you can't do that. Remember, you can't put the negative sign, you can't put the negative term in front when you're doing the square, the something squared minus something squared formula. All right. You have to keep it where it's positive first and then negative second. So if we do that, though, we get this right here, 2 squared minus 5x squared like this. And so that's going to lead to what? That's going to lead to 2 and 2 in the front, 5x and 5x in the back, all right, and then minus and plus. So what do we got here? We've got single red one because that's prime. We have 2 red ones because we got 2 brackets, okay, with multiple terms inside of those brackets. So no green ones. We skip the green step. We go to the red step and we think, oh, wait a second. It doesn't look like any of these are the same, okay? By the way, even if they're in a different order, you guys, if both of the terms have the same sign in both the top and the bottom here, then you can cancel, all right? Even if they're in a different order. But the problem is that the signs aren't the same on either one of these two on the bottom as compared to the top. Let's check it out. Here you got positive 5 minus 2, right? Down here you got positive 2 minus 5, so that's not the same. Here you got positive 2, positive 5. They're both positive, so that's not exactly the same either because the 2 is negative up here. So nothing's the same. But remember I said there is one exception to this idea that the red ones have to be exactly the same, and it's this. Let me show you on a piece of scratch paper if you've never seen this before or maybe you don't remember. So let's say you had x minus 3 and 3 minus x. Please do not write this down normally. I just want you to understand the shortcut that I'm about ready to show you. Notice that x and negative x are opposite sign. 3 and negative 3 are also opposite sign. They both have the opposite sign as the term down below it. So when that happens, again, don't do this. This is the long way. But if I factor out the negative 1 right here, there's a reason for this. I'll explain. You end up getting this right here. Okay. And notice that gives me what? That gives me a couple of reds there. And then a green one here. Remember, you're allowed to cancel red ones if they're exactly the same, even if they're in a different order. Sure enough, they are exactly the same because you have negative x, positive 3, positive 3. Since both of the signs are the same, this truly is the same, even though it's in a different order. So that means I can say 1 over 1 since they're exactly the same. With that in mind, you guys, what's the final answer there? Negative 1 over 1. Now, here's the shortcut. If you see two factors here, and they're both red, okay, if they have opposite signs, not on just one of the terms, but on both of them, x and negative x, 3 and negative 3, all right, again, it's got to be both terms opposite. Then you just simply, as a shortcut, cancel those out, but instead of writing 1 over 1, you write negative 1 over 1, because that's exactly what it should be, as we see over here, negative 1 over 1. So let's try that out here, you guys. Okay. 5x minus 2. Which one of these two brackets does it have opposite signs on both terms? It's going to be this one, isn't it? Negative 2, positive 5, negative 5. They're both opposite sign, so that's the one that you can do the negative 1 over 1 thing with. Okay, you can't do it with the other one because only the 2's were opposite signs, but not the 5s. So that you can't do. All right, so we're now done canceling. And we get what? We get negative 1 over, and then on the bottom we have 1 times a bracket. So we just say that it's equal to the inside of the bracket. Okay. So keep that in mind. Look for that opposite sign thing going on, all right, in addition to the fact that you need to cancel red ones that are exactly the same. Problem F. The top here has a GCF, I factored it out right there. Okay. That is equal, or that is what? That's a green one and a red one, because GCF times bracket means green times red. Now notice on the bottom, that looks like they already factored it for us. Whenever you got a bracket, or pardon me, a term times a bracket, or a bracket times a bracket, like we've seen so many times here, or if you even have a term times a bracket, those are the types of factored forms that you're going to see in these problems. And sometimes you could even just get three brackets being multiplied occasionally too. Anyway, those are what we call factored forms that we're familiar with. This is one of them when you got a term times a bracket. All right, so that is already been factored, other than the fact that you just need to check to make sure that the bracket is prime. You never have to factor a single term, all right? But just check the bracket to make sure it's prime, and sure enough it is, because it has two terms and it has y to the first power. So that's definitely prime. So here we go here. Remember we said, if you've got a green one on both the top and the bottom, you can try to cancel that if that's possible. Sure enough, we can cancel the y's since they're exactly the same. By the way, you don't need to do that. Just as a reminder, you don't have to do that thing where you subtract the exponents if the exponents are the same. It's just going to become 1 over 1 on those variables. Just like two brackets that are the same become 1 over 1, the y and the y become 1 over 1 for the same reason. They are exactly the same variable and same exponent too. Okay, so that leaves me with what here? Well, I can't cancel the reds because they're not exactly the same, and they don't have that opposite sign thing going on either. Remember, don't cancel the y's. That's only part of the red factors. That's not allowed when it's just part of it. So that just leaves me with this right here. Okay, so that is how we put fractions in lowest terms. All right, go ahead and try those last two problems on the bottom of the page there, and we'll take a look at those answers here after you hit play once again. Okay, so let's see how number 1 comes out right here. Again, we have a more than one term on the top and bottom, so don't even think about doing anything else until you factor first. Factoring the top and the bottom, we get those factors that you see right there. It's the Berry method on both of those. Okay, and so we get x minus 2 and x minus 5. On the bottom, we get x minus 5. I know it's hard to see because I did the canceling all in one line right there. But x minus 5 and x plus 1 on the bottom. X minus 5, x plus 1. Since the x minus 5 and x minus 5 are the same, you're allowed to cancel those, and we get this right here. Okay, that's number 1. Next one here, the top is what? The top is 5 minus x and 5 plus x. Remember, don't try to put the x squared in front because it's negative. You're not allowed to do that. And no, that is not equal to x squared minus 25 because that means that you're changing the signs of both the x squared and the 25. That's not allowed either. Okay. Not unless you do something unusual like factoring out a negative or something. All right. Not saying that that's completely wrong, but it's just easier to keep it the way it is. All right. So don't do that unless you're sure you know what you're doing. Okay. But that it is possible, but this is easier. So factoring the bottom with the Berry method, we get what you see there. Again, this is x minus 5. Okay. And above that is 5 minus x. Notice that 5 minus x and x minus 5 have that same term opposite sign thing going on. Both of the terms are opposite sign, not just one of them. That's why you can't cancel the 5 plus x. The 5's are opposite, but the x's are both positive. Not going to work. So you have to cancel these two because they're both opposite sign. When they're both opposite sign, we don't say 1 over 1. We say negative 1 over 1. Now, here's something we haven't seen yet. I've got negative 1 times a bracket. You can't just say negative 1 times and then get rid of the bracket. You can't do that. There is a way to get rid of the bracket, but you got to be careful. There's 2 different ways to do this. When you have anything else other than 1 times a bracket, you've got to keep the bracket unless you distribute it out. Let me say that one more time. Because in a lot of these other problems, we had 1 positive 1 times a bracket. In that case, it's just equal to the bracket, and you can get rid of the bracket. But if it's negative 1 times a bracket, then one of 2 things that you can do. You could just keep the bracket like this. And I'm fine with that. You don't have to distribute this out. That's not required. You can if you want, just as long as you know what you're doing. But you can keep that way. All right. What I'm concerned about is you cancel everything you possibly can. If there's still some brackets in your answer being multiplied by something, I'm not overly concerned about that on these problems. So you can keep it that way. But if you are going to get rid of the bracket, then you have to distribute the negative 1 through there, because the bracket officially is still supposed to be there when you are multiplying by anything else other than positive 1. See, what I'm concerned about is I'm concerned that people are going to write, and you can see I crossed this out here. See how I wrote down negative 5 plus x? Okay. That is not correct, but a lot of people would do that. They would just take the negative and push it up next to the 5. No, that's not correct. You've got to put a bracket around, you got to keep the bracket rather around the 5 plus x, and you either put a negative 1 in front of it, just like it says up here, just write it the same way, negative 1 and then the bracket, or you could distribute that out and you get this right here. Okay. You don't need to do this thing right up here. I only wrote that down because a student asked me about that one time. That's something that's rare to do. Don't worry about that. The main thing I wanted to mention was that these 2 are both fine. Yes, this one up here is fine as well, but these 2 are the main ones that you usually consider doing. So anything other than 1 being multiplied by the bracket, you either bring down that term and keep the bracket, or you distribute it through the bracket. But you don't just get rid of the bracket like I did over here. I was pretending, but like I did over here, and just throw the negative in front of you. You can't do that. That's not allowed. Okay, so these 2 answers are what you want. Either one of them. You don't have to say both of them. Either one is fine. Okay? And let's go ahead and take our front side of the worksheet here that we just completed and flip it over to the back side. And you see on the back side we have multiplying and dividing fractions. Okay. Now, when you multiply and divide, the reason why we're talking about it in the same section is because there is so much similarity between what we have on the front and what we have here on the back. So when you multiply fractions together, if it's just simple little fractions like this, like 3/4 times, say, 5/7, then it's okay to just multiply them together, and then you'd put the answer in lowest terms. You multiply the top and the bottom. Okay, that answer actually is already in lowest terms. Everything's great. But the problem is that when your numerators and denominators are bigger than that, especially when they've got more than one term in any of those 4 things here on the top and bottom, okay, you can see that 3 of the 4 things have more than one term here. In that case, you do not, very, very important, you do not want to multiply yet. Yes, we eventually will be, as the directions tell us to do, but you want to do what we did on the front side of the worksheet first. Again, this is just with multiplication. Division is going to be very similar as well, as you'll find out. But you're going to want to factor and cancel just like we did on the front. Very important, because ultimately, as it says in the directions on the front, let's go ahead and look at that here. When we multiply and divide, and it just says multiply here, but division is going to be very closely tied into that. It says that we need to factor and cancel here. That's going to enable, or that's going to cause it to be in lowest terms. If you do it correctly, your final answer will be. So let me make a little reminder here. Final answer must be in lowest terms. Okay, and the only way to make that happen is to do your factoring and canceling first before you actually multiply the numerators and denominators together. It wasn't as big of a deal here because the terms, we just had a single term in the top and bottom of all 4 places right here. So not as big of a deal. You could still get it in lowest terms, even if it wasn't already. You could easily get into the lowest terms in a small situation like that. But here, no. So what we do then is we do the same thing we do on the front. It's just that we do it with both fractions. Okay, and then I'll talk about what to do after that. So x squared minus 25. GCF is 1. We factor, since that's two terms, we end up getting x squared minus 5 squared. X squared minus 5 squared, and that's why it leads to x minus 5x plus 5. Okay. Underneath that, that looks like the Berry method. Again, the GCF is 1. The Berry method we're going to get, it looks like, in fact it is, going to be negative 5 and 2. All right, negative 10. All right, we need negative 3 in the middle. And so that's going to be negative 5 and 2. All right, and so therefore we put that right there. Okay. Now, we also got to do the other one here, but the other one is x plus 2. That's already prime. Okay. So that's just a prime polynomial right there, just a single red one when that happens, as we talked about on the front. These are just these are just two different red ones on both of those. All right. Again, we identify our factors, red and green. We do it exactly the same way we did on the front when we're just trying to take a single fraction and put it in the lowest terms. It works the same way. And then, as we talked about on the front also, if you have just a single term in any one of your denominators or numerators, that's just a single green one. You don't have to factor it. Okay. So just like we talked about on the front, after you factor and after you identify your factors, you then cancel what you can. Now, we also talked about how if you have a green one just on the bottom but not on the top, can't cancel. You got to have at least one green one on both the top and the bottom in order to be able to combine them together to cancel them. Okay, so you can never cancel a red with a green, ever. All right. So then, since we can't cancel the green one here, we go to the red ones, and the rule on the red ones was what? If they are exactly the same, or if they've got that opposite sign thing going on that we talked about. So these two are exactly the same, right? And what else? And make that 1 over 1 just like before. These also are exactly the same, and they're both red factors, so we can do that one as well, 1 and 1 there. Let me just clean up my mess here. I can't cancel anything else. We got 1 times x plus 5. I'm going to figure out what all 4 of these things are equal to, the 2 numerators and the 2 denominators. Underneath that is 1 times 1, so I put 1 right here. Over here in this fraction, I get 1 and x. Now that I've cleaned up that mess, I've gotten rid of all the, the cancel marks and all that. Finally, you guys, we've got this much more simplified thing that we can multiply together. It is at this point, after you have factored and canceled and you cleaned up your mess and all that, finally now we can actually multiply the fractions together by multiplying the tops and multiplying the bottoms. And we get what? We get x plus 5 over x. Okay, and that's your final answer right there. And you can be certain that that's in lowest terms as long as you're sure that you canceled everything that you could possibly cancel back over here. All right. Now, you might be thinking, well, would it have been so terrible just to multiply the numerators and denominators together on the first step and then factored and canceled after that? Well, a lot of times, you guys, not always, but a lot of times that would have led to some answers there that would have been too hard to factor and cancel. It depends on the situation, but I can tell you right now, this will always work to actually factor and cancel first before you actually multiply the fractions together at the end. And that's why we do it that way. Okay. Let's go over to problem H right here. We'll do the same thing. You can see here that, again, we need to factor and cancel first, like we said. Oh, by the way, one other thing I forgot to mention. I did it without talking about why. Notice I cross-canceled right there. I went from one fraction to the other. Are you allowed to do that on any pair of fractions that are right next to each other like that? The answer is no. You cannot do that all the time. You can only cross cancel. Let's write this down. You can only cross cancel when what? When you are multiplying. That's the key word there, multiplying fractions. Not just anything. In other words, in the next section, you guys, we are going to be adding and subtracting fractions. In that case, you cannot cross cancel. Okay. Just when you're multiplying. Now, let's go on to the next one there. All right. So that was the reason why I canceled those, though. All right. I wanted to make that clear. All right. Problem H. We have what here? We have a Berry method on this first numerator, don't we? Okay, and it ends up being, and I'll go ahead and just jump to it since we've talked about the Berry method enough times. Okay, again, always let me know if you're having trouble with that, but for now I'm just going to do it. It's going to be x plus 3 and x plus 3. 3 and 3 are the two numbers that you do there. The last step of the Berry method does not need to be done because both of those brackets already have a GCF of 1. So if you do that last step, it's still going to be the same answer there. The one underneath that is similar, all right, 25 and negative 10, that leads to minus 5, minus 5, all right. All four of these brackets are prime, so I'm going to go ahead and identify those as red factors because they have more than one term in them. Red factors, remember, means the factors have more than one term. And here's something we haven't seen before. We have brackets taken to a power in these problems where we got to factor and cancel. We haven't seen those before. When you see that, you guys, in order to be able to do the canceling step, I want you to take, whenever you have a bracket, not just a term or something like that, but an entire bracket with more than one term in it, like x minus 5. If you see that taken to a power, I want you to expand it out like this. And I'm writing it 3 times because it's to the third power, like this. So expand that out. It makes it easier to do the canceling step here. And when you have 3 brackets being multiplied together, we saw this. We talked about it earlier. That's just 3 red ones there. All right, because they all have more than one term. So we got all these red ones. We don't have any green ones, but looking at the red ones, we can cancel them if they are exactly the same. And as it turns out, there's a lot of them that are. Remember, you guys, very important, you have to pick one on top and one on the bottom. You probably knew that already, but I just wanted to make sure. All right, when you cancel, it's always got to be one thing on top and one thing on the bottom. It doesn't matter if you're talking about red or green. All right, so you got to do green on top, green on the bottom, if there was any green ones, and then with the red ones. In other words, don't cancel these two. Okay, I know they're the same, but they're both on the bottom, right? So you don't want to cancel those together. But you can cancel one red one on top with one red one on the bottom as long as they're the same or they have that opposite sign thing going on that we talked about. So we got 1 and 1 right there. These two are also the same right here. These two I'm pointing at, and so that's going to be 1 and 1 as well. X plus 3 and x plus 3, we can do that one there. You got to do 1 for 1. Don't try to do 1 x plus 3. Don't try to do 1 x plus 3 with a couple of x plus 3s at the same time. You can't do that. 1 with 1. Same thing here. 1 of these with 1 of these. That you're allowed to do that. And so that's all we got left to cancel, right? We can't cancel these here. Not allowed to cancel the x's because the x's are... Actually, I can fit that in. We can't cancel those x's right there because they're part of a multiple term red factor, and you're not allowed to cancel part of a red factor. So what we get here after I clean up my slash marks here, my cancel marks, I get 1 over 1 on the first fraction. On the second one, I get 1 times 1 times a bracket. As we talked about already, 1 times 1 times a bracket is just equal to the inside of the bracket when you multiply by positive 1. And same thing down here for the same reason, x plus 3. So what happens now after I've done all this stuff here and I've made it much simpler, I can now multiply these together and the final answer is x minus 5 over x plus 3. There we go. Okay? So what I'd like you to do right now is please try problems 3 and 4. Okay, and go ahead and hit the play button when you're ready to look at those answers, and we'll take a look at those at that time. Okay, so let's take a look at those answers in 3 and 4. You can see that I've already factored everything so that we can see what we have in front of us here. Just factored in the same way we normally factor. Identified our factors in the same way that we normally would do that. We did that on the front side of the worksheet. We did that in the first couple problems here on the back. By the way, you guys, I just want to make it clear, when you write out your notes and your homework and your test and everything, you don't need to go out and buy a red pen or a green pen or anything like that, just in case any of you are wondering that. I'm just doing the red and the green just to help you understand better what the difference is between the red ones and the green ones. It's just easier to show it that way. So don't worry about that. If you want to do that, and if you want to get those red and green pens to make it easier on you, then you're certainly welcome to do that. Okay, but it's up to you. Now, let's go ahead and do some canceling here since I'm done factoring and identifying my factors. Here I can match up x minus 1 with x minus 1. They're exactly the same, so that would be 1 over 1. I can match up this x minus 1 with this x minus 1 down here. Very similar to problem H, in fact. Very similar format. X minus 2 can be done with x minus 2 here. And then I can match up this x minus 2 down here with this one up here. And that leaves me, again, very similar looking problem to the last one. We end up getting 1 times 1 on both the top and the bottom of the first fraction. So that gives me a couple of 1s right there. And then on the second fraction, multiplying by 1s, a bracket times the 1s, like we said before, it's just going to be equal to the inside of the bracket, x minus 2 and x minus 1. So my final answer then, after I finally am ready, after all the factoring and canceling, I'm finally ready to multiply the fractions together, I get x minus 2 over x minus 1. Okay. And so now, and that, again, that should be in lowest terms already, all right? You shouldn't need to have to cancel anything else. So you can be confident, as long as you're sure you've canceled everything, that should already be in lowest terms, all right? And as we talked about yesterday, or whenever you looked at the 6.1 worksheet, whenever that may be, on the front side of the worksheet, we talked about at that point that these two things right here cannot be canceled because these are both red ones. All right, and there's a way to check that in your final answer. We talked about that in the front side of the worksheet. You can do that here again. But I can assure you, though, you don't even need to do that check, though. This should already be in lowest terms, and you should be confident about that if you're certain that you canceled everything that you could over here. But you could check your answer to make sure it's in lowest terms using the same technique we talked about on the front side of the worksheet. That's if you want to make absolutely sure it's in lowest terms. Okay. Over here, again, we have a green one on top and green one on the bottom. So we have to try, when we have a green one on top and green one on the bottom, we have to try to cancel those. And the way you do it is you pretend like 2 and y is like its own separate problem over here, and then you cancel it in the same way. But nothing cancels, does it? And so just like nothing would cancel if this thing was separated off to the side here, nothing will cancel for the same reason here between the 2 and the y. So we skip the green ones. We leave those alone because they're not going to cancel. And then we go over to the red ones here. And you can see here that these two are exactly the same. So I can cancel those 1 and 1. But then we have this opposite sign thing going on that we talked about on the front side of the worksheet. Where we have, notice these two have the opposite sign on both. -1, +1, positive y, negative y. Okay, don't do the y plus 1 because only one of the terms has opposite sign. The ones do not have opposite. So you can't do it when only one of them is opposite. All right. So I can do this one and this one because both of the terms have opposite sign. But remember, it's not 1 and 1 when you do that. It is -1 and 1, just like we talked about on the front of the worksheet. So let's clean up this mess here. We got 2 times 1 on the top of the first fraction. We got y plus 1 underneath that. On the second fraction, I got -1 over y times 1 is y. Now, when we actually multiply that together, you guys need to remember something important here. And the top part here is easy. 2 times -1 is -2, right? Okay, that part was simple enough. But when you multiply, you guys, by a denominator that has more than one term in it, you have to put that in parentheses. You could put the y behind the bracket if you want. I like to put, whenever I have a single term being multiplied by something that has to be bracketed, I usually like to put the single term in front because that's usually easier. That's something that we're more used to. And when you multiply, it doesn't matter what order you put the two things in that you're multiplying. So I put the y in front. But again, we have to bracket the y plus 1 because we are multiplying by the entire denominator. And so if the denominator has more than one term, like I've said before, if you've got something with more than one term and you're supposed to multiply the entire thing by something other than 1 is different, but anything else other than 1, in this case we're multiplying by y, not 1, we then have to bracket the y plus 1. And yes, you could distribute out that bracket. I kind of talked about that on the front side of the worksheet. If your final answer has brackets in it, you could distribute them out, but it's not necessary. You could do it either way. Okay. What's important is you canceled everything you could before you multiplied. All right, so let's continue on here with a couple more lettered problems here, and then I'll let you guys try the last two yourself. In problem I here, you can see that, well, maybe you don't see it yet, and that's okay. That's okay if you don't. But let's just go ahead and go through the normal process here. 2 minus y is prime, so we can't factor that, but let's try to factor everything else here. This one has a GCF of y, and then the resulting bracket right there is actually prime because it has two terms in it, 5y plus 1, and it has y to the first power. That is automatically a prime situation, as we've talked about before with brackets. All right, this thing was prime, so that's just a single red one up there. 10y plus 2, we can factor a 2 out of that, and we get this. Okay. And then underneath that, we get y minus 2 and y plus 2 if you factor y squared minus 4. All right. So we get, let me just identify my factors here with my pen. Very similar to the last problem here, we have a couple of green ones. In fact, they're exactly the same two green ones we saw before. That's just a coincidence, of course. That's just how it worked out. But we can't cancel 2 and y, right? So we leave those alone since we can't cancel them, and we move on to the step where we cancel the red ones. These two red ones right here, 5y plus 1 and 5y plus 1, they are exactly the same, so we do 1 and 1. 2 minus y and y minus 2 have that opposite sign thing going on. But do not do y plus 2 because only the y's are opposite sign if you look at y plus 2. The 2's are not, so you can't do that one. They both have to have opposite sign in order to do this negative 1 over 1 thing. Okay. Now, so now I have canceled everything I possibly can. Let's see what I got left here, cleaning up my mess here. I've got negative 1 over y on the first fraction over here. And then on the second fraction, I've got 2 times 1 on the top, y plus 2 on the bottom. You can see it's a very, very similar problem to the last one. And we get what? Negative 2 on top. And as we said, when you got a single term times multiple term in the denominators, since you have to multiply the entire denominator, you got to bracket the one that has more than one term in it, like that. And now that you've got that answer, you are welcome to distribute out the bottom there since it's got a bracket, but you don't have to, like I said in the last problem. Okay, so that finally brings us now to division of fractions. Here's the good news with division of fractions. It's exactly the same as multiplying fractions, except for you have to do one extra step. But that one extra step must be done first. Okay, do not even think about canceling when it's still a division problem. You got to convert it to multiplication first. Why is that so important? It's because you're only allowed to cross cancel when you're multiplying. I've seen lots of students, they will forget to take care of this first step I'm going to show you here to convert it to a multiplication problem. It'll therefore still be a division problem, and then they will cross cancel when it's still a division problem. And that's wrong because you can only do it when it's a multiplication problem. So it makes logical sense, in other words, to convert to a multiplication so that you can then cross cancel. All right, let's do that right now. How do we take two fractions that are being divided and convert that to a multiplication problem? what we do, a lot of you probably remember this, what you do is you flip the second fraction. You keep the first fraction the same, but you flip the second one, and then it simultaneously becomes a multiplication problem. So you change the division symbol to a multiplication symbol simultaneously. Okay? And once it becomes a multiplication problem, you guys, you just do all the same stuff we just learned, because it's a multiplication problem now. And let's do that. So 7 and 28, those are just single terms. We don't have to factor single terms. They're just single green ones when you do that. Y minus 5 actually already is prime, so that's a single red one. But the 3y minus 15 can be factors. So let me go ahead and write that out here. That becomes 3 bracket y minus 5 if you factor out the GCF there. And y minus 5 is prime, so I don't need to factor that second numerator any further there. Let me just rewrite all my reds and greens here so we can see them. Okay. Now, this time, for the first time, we actually have more than 2 green ones. We have 3 of them. Let me zoom in there for you so you can see that. So 7, okay, 7, 3, and 28. 7, 3, and 28. You remember, you have to pick one on top and one on the bottom. You can't combine the 7 and the 3 and try to cancel them both of 28. Not that that would work anyway in this case, but sometimes it might. But you have to pick one green with one green. One on top, one on the bottom. Can't I cancel 7 and 28? Okay. Just like if it was its own separate problem, 7 over 28. What would 7 over 28 become if it was its own separate problem like that? It would become 1 over 4. It would reduce down to 1/4, wouldn't it? So in the same way, this would become 1 and 4. But now you still got to look at the 1 and the 4 along with the 3, since that hasn't been touched yet. Can I cancel anything between 1, 3, and 4? If you can, do it. If you can't, then leave it alone. And sure enough, you can't. All right, nothing cancels. There's no common factors to divide by. So what about the red ones? Well, as it turns out, both of the red ones are exactly the same, and so they become 1 and 1. And now we're done with the red ones. We're done with the red ones. We're done with the green ones. That means we're ready to clean up all of our cancel marks here before we multiply this all together. We get 1 over 1 on the first fraction. We get 3 times 1 on the second fraction divided by 4. Well, that's a pretty simple thing, isn't it? Okay, that turned out pretty simple, huh? And so we multiply those fractions together finally, and we get 3/4. Okay. Now, so in these last two problems here, you'll notice that both of them are division problems. So the key thing is to remember to flip the second fraction, not the first fraction, but just the second one. Before you go ahead and do all the multiplication stuff, factoring, canceling, multiplying the fractions together, all that stuff, okay? One additional note, notice in number 6 you have just a regular polynomial, not a fraction, being divided with a fraction. Whenever you're multiplying or dividing and one of the two things is a fraction and the other one's not, you make the other one into a fraction. You make the other one into a fraction, and then you go ahead and go through the normal process. And since this is division, you'll flip the second fraction, all that same stuff. Okay, so I just want to make sure you saw that there. Please go ahead and try 5 and 6, and then I'll go ahead and take a look at the answers here when you hit the play button once again. Okay, so here number 5, you can see that I've already set up the factoring. Remember, you flip it first, then you factor now that it's a multiplication problem, and now you can once again see that I have 3 green ones. Can I cancel anything between x, 15, and 5? Yes, I can. I can cancel 15 and 5. That becomes 1 and 3. Now, can I cancel anything between x, 1, and 3? No, I cannot. And so that means I'm done with the green ones now. I then jump over to the red ones. Both of the red ones we do have are exactly the same. And so I cancel those. And now I'm done with both the reds and the greens. First fraction then is going to be x over 3 here. As you can see, x times 1 and then 3 on the bottom. The other fraction is just 1 and 1. And so we just then multiply those fractions together. Anytime you multiply by 1, it doesn't change what you're multiplying. Final answer then would just be x plus, or pardon me, x divided by 3, x over 3. So that is number 5. In number 6, we do the same thing here. Since it's a division problem, we have to flip that second fraction, and then we cancel everything that we possibly, or pardon me, we factor everything that we can. All right, now we have just a single green one down here. So when that happens, you don't cancel with the green because you got to have another one up above that in order to be able to cancel with it. So then we move over to the red ones, and actually there's only one pair that you can cancel, x plus 5 and x plus 5. All right, so let's clean up our mess here. I've canceled all the red ones I possibly can, and that leads me to x minus 1 over 1. This one is x plus 7 over x minus 5. How do I multiply those together? Now remember what we talked about. If you have a numerator or denominator, doesn't matter which one, that has more than one term in it, you have to bracket it when you multiply by the other numerator or denominator, like that. Because they both have more than one term, you got to bracket both of them. Now remember, the x minus 5 you don't have to bracket, because the exception to that rule where you got to bracket it is if that multiple term denominator is being multiplied by positive 1. If it's being multiplied by positive 1, all right, then you don't need to bracket that. So you need to bracket the x minus 1 and x plus 7 because they are both have more than one term in it. As you can see, I did that here. And then the x minus 5 you don't have to bracket because it's being multiplied by positive 1. So again, this is the final answer. That's an acceptable answer. If you want to distribute out your parentheses or multiply those out, you can as well. Just make sure, you guys, that in that final answer, if you want to clear out your parentheses by multiplying them out, make sure that you have canceled everything that you possibly could have first, which you should have if it's the final answer, but I'm just making sure to remind you to be extra careful with that. But you can certainly leave the answer like this too with the brackets. Again, what's important is that you have canceled everything first before you multiply and combine the two fractions together. All right. When you multiply, if the brackets are there, again, that's all right. Okay, when you actually bring the two fractions together by multiplying. And so one other reminder here as we finish up this section. As you can see, there's still a lot of factoring going on. A lot of factoring that we learned in Chapter 5 about how to factor. Make sure that you let me know if you're still struggling with factoring, because we're going to see plenty more of that here, especially in the next few sections. And so you don't want to fall behind, okay? And so that, anyway, that wraps up section 6.1. Let me know, as usual, not just about the factoring, but about anything else if you have any questions. Take care.